Okay, this lesson is a three-part lesson on the chapter of energy, work, and power. So let's dive in. So what I'm going to teach in this lesson, we're going to teach about conservation of energy and efficiency. Okay, so this video is just on this basic idea of conservation of energy and efficiency. So in the next lesson, we're going to talk about work done, and the last lesson will be on gravitational potential energy and kinetic energy. So first of all, the first question I would like to ask you is, what is energy? All right, energy is actually the capacity to do work. All right, it's like why are we able to move, to walk, to run, to jump? Okay, that is a form of work, and to be able to do that is actually because we possess energy. All right, so the unit of energy is joules, and it must be written in capital letter because it is a name of a person, and the letter is J, and the scalar it is a scalar quantity. It doesn't have any direction. All right. So let's move on. The first thing, if you want to understand energy, is you must first know that energy has to be conserved. And what does conservation of energy means? Okay, this is the definition for conservation of energy. The principle of conservation of energy states that energy cannot be created nor destroyed, but it can be converted from one form to another. The total energy in an isolated system is always constant. I know that this may be a mouthful. I'll try to use an example to explain this. So let's give this example of switching on a television. What is the energy conversion that takes place when you turn on a television for its normal use? So first of all, you'll say that we start with electrical energy, all right, because it's plugged into the main socket in the wall. And then after that, the energy is converted to light energy, sound energy, and heat energy. Light energy for you to see the video or the show, sound energy to hear the show, and lastly, heat energy because after a while the television will be a bit warm. All right. So the electrical energy will be what we call input energy. Let's give a hypothetical value. Let's say we use the television for a short time, and the total input energy is 1000 joules. All right. So let's say that light energy, the energy that's converted, 600 joules of it is converted to light energy, and then another 300 joules is converted to sound energy. So if based on the conservation of energy, what we expect to be the amount of heat energy? Obviously, it will be 100 joules. Why? Because the total energy that we start with must be equal to the total energy that we end with. So that means that the input energy, which is 1000 joules, must be equal to the total output energy. And what I meant by total is the sum of all the energy output, because the electrical energy in this case is converted to many forms of energy, but the sum of all the energies is equal to the original input energy, input electrical energy. All right. So another thing I would like to say is that light energy and sound energy are considered to be useful energy. What do I mean by useful energy? Useful energy are energy that will help the appliances or the device that is converting the energy to meet its use. Like for example, in the case of a television, all right, the television is used for us to watch television show, to listen to the show. So obviously light and sound energy are important useful energy for it to achieve its purpose. Heat energy, on the other hand, is something that we can do without. It is an energy that is lost, okay, And even if you have a lot of heat energy given out from a television, it's not going to improve the effectiveness of the television for its purpose and use. So if you have a television that doesn't give off any heat, very, very cold after 10 hours of use, that will be a very ideal television because you don't have any loss of energy. So do take note, you need to know the idea of conservation energy, the input energy is equal to output energy, as well as the difference between useful energy and energy loss or unwanted energy for this lesson. Alright, I'm going to move on. So there are two situations that we study. Alright, in real life, it is usually what we call the non-ideal situation, and in ideal situation is where we have a situation where we don't have any energy loss. So let's look at these two cases. In a non-ideal situation, for the television example, is that the energy converted is converted to light energy, sound energy, and heat energy. So there is always some not 100% transmission or conversion into useful energy, but there will always be some energy loss. Alright, so in a non-ideal situation, there's always some energy loss. Alright, but in an ideal situation, if let's say if a TV that doesn't have any energy loss, then you will probably have a television that only gives off light and sound energy, and there is no heat energy whatsoever. So in this case, the useful energy becomes 100%. So in the first case, the useful energy is 90% of the input energy, while in the second case, the useful energy is 100% of the input energy. Okay, how did I I did not mention how did I arrive at the 90% value. The 90% value actually comes from the previous question. Right, here is the 600 and 300. So if you add up, it's 900 joules. 900 joules out of the input energy is 90% of the input energy. That's how I arrive at that 90%. Alright, so I'm using the previous example of the television. Alright, so let's move on. So with the situation of the non-ideal case, that's why we have to talk about this next term, which is efficiency. Alright, so first of all, based on conservation of energy, of course, input energy is equal to output energy. And then because in real life, non-ideal situation, it is not possible to convert 100% of your energy into useful energy. Some energy is always lost as unwanted energy or energy loss. Alright, example is heat energy. Hence, this gives rise to the term of efficiency. Alright, so what is efficiency? So in a nutshell, efficiency is equal to the useful energy output divided by the energy input times 100%. So it's a ratio of the useful energy output divided by the energy input. Be careful, because this output must be the useful energy, not the total energy. It must be the particular energy that we want the device to function. Okay, so let's look at 3 examples in a non-ideal situation. Let's say you have a light bulb. Alright, energy conversion of a light bulb usually is electrical energy to light and heat energy. Alright, so what is useful energy for a light bulb, and what is unwanted energy? So obviously the useful energy is it gives off light. So the useful energy is light, while the unwanted energy is heat. If you can have a light bulb that has no heat generated, is the best. For example, if you have a filament light versus a LED light, you realize that LED light is very cold while filament light is very hot. So if that means that the energy loss by the LED light is significantly lower than that of the filament light. Alright, so in terms of efficiency, of course, the LED light is much better. Alright, so let's move on. Fan. Okay, fan, electrical energy to kinetic energy and heat energy. Bear in mind, kinetic energy refers to the spinning of the fan, which generates wind. But wind is also kinetic energy. It's not your wind energy. There's no such thing as wind energy. All right. So which one is the useful energy? Of course, the kinetic energy. And which one is not useful? Heat energy again, because after a while the fan usually becomes warm. All right. So let's move on. Hair dryer. Now in this case, you realize that heat energy no longer becomes energy loss or unwanted energy, but it becomes a useful energy, because you will need heat and kinetic energy to blow dry your hair. So that means that the kinetic energy refers to wind energy. It refers to the wind generated due to the movement of wind. All right. So again, heat and kinetic energy is necessary, and so is useful energy, while sound energy, which is always generated because hair dryer are very noisy, is energy that is wasted. So if you have a hair dryer that is totally quiet, you'll be even better. Right? So if you look at these three examples, you realize that there is something that I also want to drive across, is that the types of energy that is useful energy and what are the types of energy that is energy loss depends on the situation. It is different for each case. That means that you cannot say that heat energy is always the unwanted energy. Alright, if you say that, then what about the hair dryer? What about an iron? What about a flame? Alright, those examples are examples where you need heat energy. Alright, so you need to look at each individual example before you judge what is useful energy and what is energy loss. Alright, energy loss may be sound energy or maybe other forms of energy. Okay, so let's move on. So how do you calculate the efficiency in that case? Let's go back to the case of the television. So we already know that the useful energy is the light and sound energy, which generates 900 joules of energy. So in other words, okay, using the formula, efficiency equal to useful energy output divided by input energy times 100%, we get 600 plus 300, which is this 2, divided by the input energy, alright, times 100. So that's how you get 90%. Okay, so that's how you calculate the efficiency. And remember what I say, that the useful energy depends on the case. Alright, so once you know the case, you write down the energy conversion, you will be able to solve for efficiency very well. Okay, so that's all for this lesson, and please view the next lesson and the subsequent one to complete this module on energy, work and power. Thank you.